Hello, I'm Jimena Ibagon, a PhD student at the State Monogastric Nutrition Laboratory at the University of Illinois, and today I'm privileged to share with you data of one of the experiments that we conducted on the effects of particle size, source, and growing region of field peas on digestibility of crude protein, amino acids, and starch by growing pigs. To begin with, I would like to give you a little bit of background about the field peas production. Field peas production is mainly cultivated for human consumption, and in the 2022 crop year, the global production was approximately 14 million metric tons per year. However, the production of field peas has been increased in the last 2 decades around 50%, and this is because field peas have a greater capacity of nitrogen fixation, and they are very easily to cultivate, and they can be used in crop rotation systems. Field peas may be cultivated in climates that are too cold for cultivation of soybeans. In the US and Canada are the North Great Plains, and there are some regions of the European Union, countries like China, Russia, and Canada, the major producers of the field peas. The nutritional value of field peas and their inclusion as a substitute in corn soybean meal-based diets for swine have been reported. However, as we will know, the nutritive value and quality of the peas may vary due to climate conditions, variation in cultivation methods, place of growing, and different varieties from breeding. Another important factor to take into account is the use of feed technologies to improve the nutritional value of the field peas. Those technologies may cause a difference in the digestibility of nutrients, and it can be difficult to predict the nutritional value of diets that contain field peas. Those processing techniques can be extrusion, pelletization, and ground of the field peas. Indeed, data demonstrate that reducing the particle size in most of ingredients may change the digestibility of energy and nutrients, and likewise, it has been demonstrated that the apparent ileal digestibility of starch and amino acids may increase when those processing techniques are applied to legumes. But it is still unknown if there is any effect of particle size and growing of region on the in vivo digestibility of starch, crude protein, and amino acids of the field peas. Therefore, the objective of this experiment was to test the null hypothesis that particle size and location of growth may affect the AID of starch, crude protein, and amino acids of field peas. Now, let's move on to the materials and methods that we used to conduct this experiment. We had 6x6 Latin square design with 6 periods and 6 diets. And as an experimental unit, we had 6 cannulated barrows with an initial body weight of 50 kilo approximately. And for the sample collection, we had 7-day period with 5 days of adaptation and 2 days of ileal digesta collection. Now, I would like to quickly explain to you the diets that we use for this experiment. We use the field peas as a whole source of protein in each diet. The 3 sources of field peas were ground to achieve 2 sizes of particle that were 200 and 400 microns. The source from the United States and 1 source of Canada were divided in the 2 batches, 200 and 400 microns, while the other source of Canada was only ground to 200 microns. This to complete 5 diets, and finally we mix an M-free diet made from sucrose and cornstarch being devoid of amino acids. With that, we complete 6 diets, and we use chromic oxide for all diets as an indigestible marker. For the statistical analysis, we used the mixed procedure of ASAS for the model, and we had as a fixed effect the field pea batch and peak and period as a random effect. And we used contrast statements to compare results from field peas ground to the 2 sizes of particles, the origin of the source, and the interactions between the source and the particle size. Now let's take a look into the results, and I want to start by talking about some nutritional characteristics. But before to start, I would like to set up my slide. In this slide, each column represents each field piece, and you can see in dark orange the content of starch and in blue the content of crude protein. We can observe that all of field peas have around 40% of starch and around 20% of crude protein approximately. Therefore, the process of grinding didn't affect the composition of the field piece. Now let's talk about of indispensable amino acids. I would like to start talking about lysine and the content for all of sources of field piece used in this experiment. It was 1.60 approximately, but the content of sulfur containing amino acids was 0.2, which is low for field piece, same as tryptophan. The content of threonine was 0.73. Now let's take a look to the apparent ileal digestibility of starch. I would like to serve my slides from now on, and we can observe that the US source in dark blue when ground to 200 microns, in light blue when ground to 400 microns, and we can see the Canada 1 source in dark and light orange, and finally the Canada 2 source in dark gray. Here we observe a statistically greater digestibility of starch in the US field piece with a reduced particle size, and it is a tendency of difference in the digestibility of starch regarding the source of field piece between the Canada and the US, which give us an interaction between the source and the particle size in the digestibility of starch. Moving to the standardized digestibility of crude protein and indispensable amino acids, we observe a statistical difference among sources with a lower digestibility of crude protein in the US source, regardless the particle size, compared with the Canada 1 and the Canada 2 sources. For the standardized ileal digestibility of amino acid in the field piece, we have the 3 sources and the 5 batches, a digestibility of lysine of around 80%, which is high in field piece. There is no difference regarding source of particle size for this amino acid. Almost the same story for tryptophan. We have a lower digestibility, but we have a statistical difference among sources, and the US source was lower in the Canadian sources. Threonine, however, had no difference among sources, neither particle size in its digestibility. And for the digestibility of methionine, even if the content is low in field piece, we have a digestibility of around 80%. But difference regarding the source were observed. Now, let's talk about the dispensable amino acids. And here, for the digestibility of alanine, we have a greater digestibility in the Canadian sources regardless of the particle size. Same story of cysteine, the digestibility was low compared with methionine, the other sulfur amino acid, and a statistical difference were observed among sources. Now we are going to finalize with glutamate, which doesn't have any difference in the digestibility related to the particle size and the source. Therefore, after these results, we came up with some conclusions. The first, that the reduction of particle size did not affect the digestibility of crude protein. The second one is that minor impact in region of cultivation was observed in the digestibility of amino acids as well as the effect of particle size. And finally, that the digestibility of a starch in vivo experiments increased in one of the sources when particle size was reduced. With that, I would like to thank Swine Innovation Pork for the funding to this project, and each member of the State Monogastric Nutrition Laboratory for their help, and to you for your attention. If you want to know more about the research conducted by this group, feel free to reach out at nutrition.nc.illinois.edu.